So this is the Econophysics 2022 presentation. My name is Zuhri and I'm one of the representatives of the National University of Malaysia's Financial Networks Research Group. And I'll be presenting our research on the causality and uncertainty of the COVID-19 pandemic to Bursa Malaysia Financial Services Index Constituents. For an overview of today's presentation, suppose we have a few of the financial sector listed companies, which in Malaysia is the most performing sector. Once their sold stocks have reached a certain threshold, these listed companies can be grouped into the large, mid or small categories, or in the literature, the term market capitalization is used. It is reasonable for some to view that the large cap could have some influence or are causal to the performance of the other smaller caps, and it is also reasonable to view that the smaller caps may not have the same influential power to the large cap. But can we prove this quantitatively? To prove this quantitatively, let's group the listed companies in a circular layout and convert them into mathematical graph knots and directed edges representing causality. Since quantitative temporal evolution of the causal graphs can be of interest, let's also employ temporal graph or graph that changes over time. Now, here's the interesting question. In the context of this research, would the other caps be impacted during uncertain times, such as COVID-19? Since causality, COVID-19 and the financial sector is of interest, hence, ladies and gentlemen, we title our research as such. And we hypothesize that during and after COVID-19, the causal intensity of these lucrative individual constituents will intensify regardless of their prominent position in Bursa Malaysia. Now, the objectives are quite straightforward. We will use Granger linear causal model to model the causality of this financial sector. Afterwards, we will use Schuber transfer entropy for a more nonlinear causal model. Afterwards, we will construct, measure, and visualize causal sources using network science. Now, let's understand causality in the context of Clive Granger's definition of causality, which is the most popular and most researched definition of causality. As an example, let's assume two public traded banks' time series. If we take the second time series data and use the data with the first time series, effectively improving the prediction of the first time series, Granger says time series 2 is causal to time series 1. However, if we reverse that scenario using the first time series with the second time series data, but it didn't improve time series 2 prediction, Granger says time series 1 is not causal to time series 2. Now, this is where it gets interesting. We can improve this measure or extend it using graph theory. Now, let's convert this into a graph or a network. What can we see once we converted it into a network? So as we can see, the graph or network has a high amount of causality for the red bank, and the orange, blue, and pink have none. Thus, what we can see is that the bank is the most influential or has the highest causality in the network. However, do note, Granger causal model is a linear model. Now let's look at a more nonlinear causal model. Schuber transfer entropy is another model for causality, but applying a more nonlinear approach. Now let's look into this model. Now, before we can look into Schuber's transfer entropy, the prerequisite concept we need to look into is Shannon's entropy, which is the measure of uncertainty. But why is Shannon's entropy important? The concept and measures of uncertainty is best described by this visual. Imagine a box over time is filled with orange balls. It is quite certain that we can always pick and get the orange balls because, well, this is the only thing that the box has. But as time progresses, suppose other colored balls appeared, and as time moves faster, more non-orange balls appeared. As we can see, the certainty of us picking and getting an orange ball gets lesser and lesser. So this is what Shannon's entropy is calculating. It calculates the certainty of a certain event occurring. Now let's look at flow of information. Suppose we have a second box that has more orange balls used together with the first box. As we can tell, the certainty of us picking and getting an orange ball gets bigger. Abstractly, there is a flow of data or information from one box to the other. And this is how Schuber transfer entropy utilizes Shannon's entropy, where data or information from a different source reduced the uncertainty of the target source. So this is identical to causality in a grander sense, where the second source enhanced the predictability of the target source. Now how do we link this to the stock market? In the context of the stock market, uncertainty is synonymous to volatility. Thus, if a second time series were able to reduce the volatility of the target time series, it is said that the second time series is causal to the first time series. So now, let's implement causality with network science. Since we know that the Bursa Malaysia financial sector is the strongest, we are going to take all 28 constituents within the financial sector and represent them as graph knots, and the edges are the causal sources. We will take the daily closing prices from the early 2018 to the end of 2021. Thus, we are looking at pre-COVID-19 up until post-COVID-19. We will also take only the strongest source of causality for this analysis. Now, we are going to group our analysis into three parts: the market capitalization, the subsectors, and the Sharia compliance. The market capitalization is again the size of the overall stocks sold for each constituent. The subsectors is the business activity for each constituent. It can be banks, it can be insurance, and it can be other financial activities. The Sharia compliance are constituents that are governed by the Islamic law. As we have built the networks, let's look at grander causal network first. Now notice during pre-COVID-19, it was the larger cap that has the highest source of causality to the other financial constituents. But again, this is during pre-COVID-19. Let's look during COVID-19 and after. Notice in 2019, it seems some of the smaller caps have increased in their causality, but it was in 2020 that the smaller caps are as big as the large caps. However, post-COVID-19 sees a rapid shrinkage of the source of the causality from the smaller caps. Now let's look at Schuber's. Similarly to grander causal networks, during pre-COVID-19, it was the larger cap that has the highest source of causality. However, over time, note the magnitude of causality that Schuber transfer entropy obtained. Note as well that it was getting more on the smaller caps causality post-COVID-19. Now, what is interesting about these findings is that although we use different methods for causality, other statistical methods from different sources are also showing similar rapid growth on other smaller caps. And these are from the Central Bank of Malaysia, Securities Commissions of Malaysia, and other prominent banks. Because we are using causality models, we can show the constituents' influential power in a quantitative form, thus providing an alternative perspective as well. So all in all, the hypothesis that the causality intensifies regardless is accepted, and all the objectives have been fulfilled. We are very pleased to inform and share as well that we have managed to publish the results on a peer-reviewed journal called Entropy. Thus, for the results and discussions on subsectors and Sharia compliance, we invite everyone to have a look into this paper we published. Thank you everyone for watching. If you have any questions, please feel free to ask.